For our systems model, we decided to take inspiration from the picture book The Little Red Caboose by Marion Potter.
This picture book was a childhood favourite of mine and tells the story of a caboose who longs to be as popular as the steam engine at the front of the train and gains the respect and admiration of all when it saves the train from rolling down a steep hill. The scene we adapted into a model was from the front cover of the story, which shows the caboose exiting a tunnel.
This book is aimed at a junior primary level, therefore this task could be adapted into the Foundations to Year 2 Design and Technology strand outcomes of the Technologies curriculum, as it involves designing solutions for technological contexts.
Additionally, this task incorporates principles from the literature strand of the English curriculum, as it requires the understanding, interpretation, and representation of a text.
Our model uses a variety of materials that are accessible and readily available for classroom use. A sturdy cardboard box was used as the base of our model, which was then covered in green felt to represent grass. Recycled cardboard boxes covered in red paper were used to construct our caboose, with further decoration made from pop sticks, wire, and a variety of coloured paper.
We glued down a strip of sandpaper to go underneath our train tracks, which were comprised of pop sticks and thick wire. To further enhance the track and add detail, we lined it with small pebbles collected from outside. The tunnel was formed using cardboard, which then went on to be covered in scrunch green craft paper to appear as if it was covered in grass.
Using cardboard, pink flowers were added to the grassy tunnel. Finally, the last touch on our design was the addition of figured people made from pegs and wool. These materials were all joined using hot glue, as it was strong and neat adhesive.
Instead of gluing the lid to the back of the box, we opted to use Velcro. This option provided a less permanent adhesive that allows for access to the systems if they need altering or fixing.
Electrical and pneumatics were the two systems used for this model. We used the pneumatics to push the little caboose out from the tunnel, and when doing this, it completes a circuit that switches the light on at the front of the caboose. Pneumatic systems use the energy stored in compressed air to create a push or pull movement. In our case, we used the push movement. To create this movement, you need 2 plastic syringes and a tube to connect the two. We connected one end of the plastic syringe to our caboose with hot glue and hid the rest of the system behind our tunnel using duct tape.
This is the inside of the caboose, where we have hidden part of the electrical wiring. The rest of the wiring and battery is underneath the base of the model, attached with tape. 2 wires are connected to the battery. One wire connects to a split pin that has been pushed through the train track, while the other wire is connected to the light bulb located inside the top of our train.
Another wire is attached to the light bulb that runs through the bottom front of our train, which is covered with tinfoil. This setup ensures that a complete circuit is formed when the pneumatics pushes forward the train and hits the split pin. Here is a demonstration of our working systems.
Initially, we had difficulty in producing our design. While we had planned and discussed our design and intentions, it was challenging trying to envisage the final product and know what materials we should use.
This dilemma was overcome by sourcing a range of materials and physically manipulating them to experiment with their potential uses. Once we could do so, the production phase was much easier.
Our next challenge arose when it came to fixing our electrical system inside our caboose. We made the mistake of constructing the caboose prior to inserting the wires, which made the process far more difficult.
While we overcame this challenge, it was a fiddly process that involved a lot of patience and consumed a large amount of time. Furthermore, it was difficult to view and access our systems because of our tunnel on our model. While our intention was to conceal our systems sufficiently, it did make accessing difficult.
We tried to overcome this by using Velcro to join the lid and the box, allowing one side of the tunnel to be lifted for further access. However, this was a production process we could have thought out more carefully.
Ultimately, we are happy with the outcome of our model, and it sufficiently meets the criteria that called for the integration of 2 working systems in a model.